All right, guys, here we are on last page of notes for day 1. And in number 2, we have circle O. AB is a diameter, and the measure of angle AOC equals 100 degrees. They want us to find the following. So first one up, they want arc AC. So from arc A to C, the short way around the circle. All right, hopefully you guys can see that that arc belongs to this little central angle in here, and so this arc is 100 degrees because central angles are equal to their arc. Next one up, arc A to D to C. So trace over your letters visually before you trace over them with your pen. You want to go from A, pick up D, travel around the circle all the way to C. So that would be arc A to D to C, and hopefully you guys can see that it's the whole other part of the circle except for that 100 degrees. So that's 360 degrees in a circle minus the 100 degrees for the arc you didn't travel, and so that's 260 degrees. Okay. Next one up is angle COB, and because it's an angle C to O to B, hopefully you guys can see that the 100 degrees and this angle we're trying to find is a linear pair. And 180 degrees, take away the 100, would leave you with 80 degrees. Next one up is arc ACB. So A in the direction of C and keep going to B. That's half my circle, and that's 180 degrees. Next is arc ADB. So from A, travel to D, stop at B. That is half the circle, which is also 180 degrees. And our last one, arc CAB. So traveling from C in the direction of A and keep going all the way to B. So that black arc that I just traced over is the entire circle except for that little arc there for CB. And if you notice that 80 degrees is the central angle, this arc would be 80 degrees. And so it's everything but 80 degrees. So 360 degrees for the whole circle, but you're not traveling that 80 degree arc there. And so if I subtract, I end up with 280 degrees. All right, let's go ahead and take a look at number 3. In the accompanied diagram of circle O, the measure of arc ACB, so from A in the direction of C all the way around to B, they're saying that that arc has a measure of 200 degrees. They would like to know the measure of central angle X. So hopefully you guys see that if we take 360 degrees for the whole way around our circle, take away the 200 degrees, we have 160 degrees left over for this arc here. So that the 200 plus the 160 would make 360 all the way around. And if you remember about central angles are equal to their arc, and therefore angle X would also equal 160 degrees. Okay, last question there, guys. Number 4 says, as shown in the diagram below, circle A has a radius of 3 and circle B has a radius of 5. Use transformations to explain why circles A and B are similar. Okay. And we're going to go ahead and say that in order to get this circle onto that one, we would have had to do maybe a translation to get circle A onto circle B. So that would be a slide. So we would say a translation along vector AB. And then once that circle gets onto there, so for instance, it probably would look something like this once we slid it over. We would have to do a dilation. Let's go ahead with, you remember new divided by old, guys? New circle divided by the old circle. Our new radius is 5, our old radius is 3, so we would have to dilate it 5/3. Okay, would be our scale factor. So a dilation centered at B with a scale factor of 5/3. Okay, so there is our transformations. And we're going to go ahead and say one more thing, that translations and dilations preserve angle measure. So the two circles are similar because they have the same shape, but not the same size. All right, so we talked about transformations and we explained why the circles, are similar. All right, guys, I'll see you on the next day of notes.